everyone, and welcome to another episode of the Outpost. We are really excited to be coming to you. It's been a while since we all hung out, but yeah, it's really great to be back. If you haven't been here before, welcome to the Outpost, your go-to place to learn about everything new, current, and interesting in the world of AI. I'm Saranya, and I have my friends here with me, Dushyant and Soham. And we are going to talk to you about what's new and interesting and caught our eye sometime this past week. Okay, and with that, let's get started. Let's move first with Soham.
Thanks, Saranya. Thanks for the amazing intro, as always. So today I'll be talking about something called RAG, right, or Retrieval Augmented Generation. So before I have some, kind of demos to show you all. And but before that, I just wanted to kind of talk to you both, right? What do you think LLMs are good at today, and what do they struggle with?
I think from my perspective, I've used LLMs mostly for summarizing, condensing large documents, getting quick, precise very quickly. And I find them fairly effective at that, in just condensing large amounts of information very quickly. I haven't tried too much reasoning simply because I think a lot of the responses I've got are like very shallow. So I haven't got any deeply reasoned perspectives, but that's just been my experience.
Plus one to Saranya's point, I think LLMs, they're fantastic when you give it a task to condense information in a kind of really easy to kind of grab way. I think they do amazing job at it. Where it has struggled is that when you try to kind of ask a question which is kind of maybe which has more than one connection, correct, where it has a dependency on like other, or where there is a leveraged knowledge, where there's an inference. I think at some of the times we have seen that its ability to give the right answer, though it gives an answer, but its ability to give the right answer is questionable at times.
Absolutely. Thanks, Dushyant, Saranya. So you're correct, right? Like LLMs are good at so many interesting things, but I think they struggle with making connections with latest information, right? LLMs are typically trained for up to a certain point in data. So if you ask latest questions or up-to-date information, if you ask it to do a task, right, like search the web or find information, it struggles at those things, right? And moreover, LLMs are also bad at specific information, right? Like if you have your own company data, right? Let's say we are an e-commerce portal and you wanted to search for information or get you insights into any part of that, right? So LLMs are not really good at that as well, right? So today I'll be talking about Retrieval Augmented Generation. So LLMs are generative AI. And the idea is, how can we use them as agents, right? Agentic AI is something that's going to be big in the next year, in my opinion, in the next few years. I think with the Google's, new Gemini launch and all these other things that are launching recently, I think that's becoming more and more clear, right? That agentic AI is going to be very important. So I'll talk a little bit about what agents can do and how you can generate content or responses based on things that you can retrieve from various places, right? So if you can augment that generative AI with data that's there in your database or the web, right, or other pieces of information, right, that becomes a lot more relevant. I have an article here which talks a little bit about RAG, right? RAG again stands for Retrieval Augmented Generation, like I talked about, right? Typically, you would ask a question to a large language model, right? In this case, just forget about the term agent here, but you would ask a query to a large language model and you would provide some context, right? You might be asking, I need help with this problem. I'm stuck in coding, I'm stuck in design or with a certain document. Can you summarize it? So all the context related to the question is in the query itself, right? Where LLMs really struggle with is stuff which is outside that context. If you don't provide enough context, LLMs will struggle. Right? So what RAG does is it augments that query with information that's present elsewhere, right? So, you might have a database of sorts, right? If you're an e-commerce site, you'll have a list of like, a lot of items, pricing information, trends, what are people buying, analytics, right? A lot of information that's there, right? So what if you could augment that generation with relevant data, right, from your database, right? Or what if you could augment it with web search, right? This is what Perplexity does, right? Perplexity uses a run-of-the-mill LLM. It could be an open source, closed source, large language model. And then what it does is it makes a web query, right? A web search using a third-party provider, gets the results, right? And then kind of passes the results back to a large language model, right? That's what happens. Imagine you could have any kind of data and you could augment your large language model with that, right? So your results are far better, right? You could ask a question about, what is the, best camera phone, right? That I can get between 10,000 and 20,000, right? Suddenly the LLM doesn't just throw an error and say, I don't know what's going on, right? It gives you a much better result. It gives you real data and kind of does that, right? So there are all these tools.
Yeah.
So in the agentic world, right, like on the RAG world, there are a couple of things. There's the query, of course. There are some tools that the agent can use, right? Which is like search engines. Typically in the AI world, right, vector search is really big because when you're talking about natural language, the phone with the best camera, right? Finding the relevant results on a normal database are very, very difficult, right? So vector database is much better at kind of retrieving, understanding the word camera and the context and kind of giving you the best results. Today, I'm here to actually talk to you about agentic RAG. So what happens in agentic RAG, and this is going to be really big next year after, right? Instead of just, sending the information, right? Like in the case of an e-commerce site, like what is the cheapest, mobile phone in this range, right? You just make a database query, take the results, pass it to the LLM, and then get results, right? That's what you would do. In agentic RAG, right? The agent is in the middle, right? So the agent kind of determines what it should do. Okay, so the agent has memory, short-term, long-term memory. It has access to a bunch of different tools, right? And then it determines what is the next course of action, right? It's able to plan, it's able to reflect, it's able to do the chain of thought, right? That Dushyant, you talked about in the previous episode, and then decide which agent to hand it over to, right? Think of, you're ordering food in an online delivery app, and you have an issue with, let's say, one item in the order itself, right? And then you reach out to somebody, and that agent decides what should you do, right? Should I actually reach out to the payments team, or should I reach out to the delivery team, right? Should I ask for a refund? What is the context here, right? So essentially, the agent can make a choice over there, right? What should I do next? And in case of RAG and agentic RAG, this agent is actually a large language model. Why? Because it can understand your context. It can understand English, right? It can understand various topics you're talking about. And then it can determine what should it do next. So maybe you have a query, right? Let's say this is an e-commerce bot, right? You ask a query, what is the cheapest mobile phone between 10,000 and 20,000, right? Then it determines this is best served by, there's a large language model, an agent over here, which is a large language model, which then determines it should send you to another large language model, which is again an agent designed to search on the site for the best device product, right? Whereas if your query would be, can you help me with the last refund? What's happening there? It goes to a different agent, right? If it's about tell me about the reviews or something, maybe there's a different agent as well. In the case of, what is the latest phone, right? And best camera device, it can do a database search, right? Get the results and then find, based on the query, what's the best, most relevant results, and then kind of combine it and get some results, right? In some other kind of solution, it will maybe do a web search, right? What are the latest reviews of this phone? What are YouTubers talking about this? Right. So this is what happens, and ultimately the result comes up and gets kind of routed back to you. I'll show you a quick demo of this. And recently we're talking about RAGs, and at the Outpost, right, we did a bunch of different RAGs, right, for our site. And before I go back, right, typically this is called a multi-agent RAG system where there are multiple LLMs which are deployed, each LLM has a capability and a task and a role to do. And they have tools that are associated with it, and they can make decisions there. I'll show you some examples of this with something that we have done recently, right? So Outpost is, of course, a site to showcase the latest in AI, right? Late AI news and so on, right? So I'll give you a couple of queries, right, that we can talk to the Outpost bot and kind of get some responses, right? This Outpost bot is a multi-agent RAG system, right? So I can ask it some questions, right? First, it kind of determines whether it should answer the question or not. What is the bounding box, right? What are the rules, right? So if I ask it a general purpose question, right? Who is Narendra Modi? This is a valid question. And typically, if you'd ask it to a chat GPT or a Claude, right, it would probably give you a response, right? Because it has that information, right? So, to be very honest, right, Outpost bot has context about Narendra Modi, but it's kind of determining that it should not reply to you, right? Apologize, your question is not specifically related to AI. Right, so there are guardrails around the system. So if you're building an RAG or a multi-agent RAG around healthcare, right, or around e-commerce, right, it will not respond to things outside of it.
It's kind of providing safety mechanism for people
Absolutely.
to. Okay. Yeah.
Absolutely. Right. So this is how you design the RAG system. And then, you can ask very specific questions. So I can ask a question around, let's say, what is Notebook LM? Right. So Notebook LM is something we've talked about this before. And interestingly, right, they have launched a bunch of really interesting updates in the last week or two. Right. And it's been in the news ever since. Right. So the Outpost has all this information that's curated from different sources and different kind of providers. It then summarizes all of this, right, and kind of gives us updates. Right. Now, based on that, right, what happened over here is first, when I asked this question, the first agent then determined that actually we should answer this. This is something which is relevant to AI, right? In fact, if you ask Narendra Modi and AI, it would probably answer, right? So there are various guardrails. So it determines it is actually useful and it should answer the question. Then determines Notebook LM is an AI-powered productivity tool that does all these interesting things. And then after doing that, it kind of retrieves all the latest news. And then decides on the fly that it should add that information, because you've asked about Notebook LM. You've not said what's the latest, news about Notebook LM, but it says recent updates have introduced interactive capabilities. AI, interact with AI hosts in real time, redesign interface, whatever, and Notebook LM Plus plan, and so on and so forth. It's a very smart system. It determines what is the topic you're talking about. It's related to Google, and it's related to Gemini 2 Flash. These are the latest news, and it's kind of contextualize it and given you an answer. And then, you could ask it questions. So what is happening with AI policy in the US last week, right? These are very general purpose questions, right? Like it's like you're talking to a person. The past week, there have been significant developments. Biden administration is focusing on final push on tech regulation, antitrust issues, right? Or, local government deploying AI without clear policies. US is planning to, planning new regulations on AI chip exports, etc. Right. So in this, right, there's a very clear time context. So I can't just retrieve all news and kind of give it back.
Just a quick thing. So when you type a query, it goes to a agent to track, and then so first of all, it determines, as you rightly mentioned, whether is this query scope of this particular agent. If it's not scope of agent, it gives you different answer. But if it is scope of agent, it will kind of go look for these different sources, try to get that answer, and then gives the response to LLM, which construct this response what we see here.
Absolutely.
And then it is okay.
Absolutely. So there are lots of agents inside this. One that determines whether it should answer or not. One that determines the context. One that determines whether there is some time context or not, right? And each one then kind of retrieves information in a relevant way, right? Some are time sensitive. Some are around a specific topic, right? Which is like where vectors would come in, right? Some are around time plus, topic or range of topics, right? And then there is a re-ranking agent, which kind of takes all of this stuff. Maybe a lot of the search results are for Notebook LM could be related to Google, right? Because they are similar, but it kind of determines what is
Right.
relevant to the query that you
Yeah.
have asked. So there's a re-ranking engine which kind of combines them and kind of gives you that result, right? Um, and then we're
Awesome.
also kind of adding citations, right? Just like attribution. That's something which is interesting. And how do we provide it in a manner that's not like just a paragraph, right? How do you make it interesting? How do you kind of share this? So all of this stuff is something that we're kind of working on. And it's interesting because if you ask Perplexity general purpose news or general purpose queries, it does really well because it does a web search and it kind of highlights that.
Yeah.
But for specific information, which are like news, uh, data like e-commerce, healthcare, right? We were working recently with a lot of doctors, and ChatGPT just gives fairly wide or broad answers, right? You need to scope it out really well and determine,
Yeah.
should I even
Yeah.
answer this or not? If I'm not confident,
Yeah.
if I'm not certain that the
Yeah.
answer is not hallucination or inaccurate, maybe I should not answer, or I should defer this, right?
Makes
So there's a bit
sense.
of chain of thought, right? So this is a little bit about RAGs. Would love to hear your thoughts, right? This is going to be big next year because a lot of responses to various things are going to be determined by RAGs, right? Almost everything can be autopiloted through all these smaller RAGs agents. Today, they are like developer bots like Devin, etc., who are like very big agents that can do various things, right? And you can communicate to the RAG just through Slack. You're not talking, you're not exposing your ID. So all of this stuff will happen next year.
So I've heard about the potential of agentic AI, and I've kind of explored some of those. But it's so amazing to see that being implemented in Outpost website. I think I
Yeah.
like
Yeah.
that
Yeah.
approach of like trying and kind of getting a feel of it. And maybe the question for both of you, maybe Saranya as well, when you wear a policy hat and so
Mhm.
on. So there's no doubt like the potential is immense. But can I use agentic AI or RAG models to create sidekicks? Like for example, we all read bunch of different news and kind of we have our favorite websites to consume news and read things out of it.
Yeah.
Can I create an agent for archive, which is like a reading a research paper, open research archive? So I'm just curious to know,
Yeah.
and what are the implications of that?
All I know is that you just described like a dream scenario where everybody has their own army of minions sent out into the world. That's my major takeaway. But Soham, you please go ahead first from a more
No,
realistic
absolutely
perspective.
correct, right? Today, most of our phones have the capability of running smaller versions of these agents offline, right? So your dream of actually running
Yeah.
multiple agents like this is definitely practical, right? You'll see this in the next few years, right? Like you can have an agent for research, an
Yeah.
agent for like your emails, right? Like everything, right? And just things will come
Yeah.
only to your attention or to your to kind of the forefront of your consciousness, right? Like only if it's needed, right? You don't have to deal with your email unless like it's absolutely needed. Maybe there's a bot or agent that deals with that, right? And it
Yeah.
and resides and it's scoped to
Yeah.
just that. It's not the entire world, right? So it's going to be
Yeah.
interesting, but yeah,
Yeah.
it's kind of weird, right? Like what will we do? That's the existential question.
I find that really interesting because you're forcing me to think about what is automatable in my life and what actually requires, paying attention. Like, for example, I will tell you, okay, this is going to sound extremely ridiculous, but like formatting long documents really calms me down. And I would never outsource that. That's my form of artwork. But should I? Should I then really focus on writing a document and leave the formatting or something otherwise inane to the agents? I don't know. This is, yeah. Yeah, Soham, thanks for the existential
That's my role
crisis.
here.
I'm just drawing a parallel here. I don't know. There was a back in time. There was an application called IFTT,
Yep.
which kind of really
Yeah,
like became so popular. Its ability to kind of connect the workflows and different things out it. So I think to me that was the first like thing of like oh, this is possible, correct. The second thing
yeah,
after IFTT was this robotic process automations or RPAs was kind of really major things. And
Yeah.
it seems like in RAG, basically agentic AI in RAGs takes this to a completely different level. Yeah, I'm looking forward to try this. Maybe I'll create. See, I don't have a hair. I have a long nose, so I'm kind of gonna write. I think the couple of bots I'm going to create. I think the first of you can guess it's
No.
Kevin. But yeah, this is super interesting. Thanks, Soham. Thanks for kind of introducing us to this.
And can I just say, as a last thought, I love that there is a world where, I mean, the pursuit of specific, contextual, relevant AI news is available. And it's really lovely that's happening on the Outpost. So thank you. Thank you for that.
So it's been interesting last few weeks and months, in fact. Actually, I'm a big fan of Nobel Prizes. I have been kind of following it quite some time, and every year that's a moment where I kind of see, okay, what new innovations are happening, predominantly because I think most of the novel innovations has impacted our life in many different ways out of it. Correct. So to me, that is like
Yeah.
one event I look forward to it. And this year's event was even special because I think we have seen some amazing winners. I think one of my favorite was Geoffrey Hinton, who is a computer scientist who has a distinguished, I would say, honor to win both a Turing Prize, Turing Award, which is the highest award for a computer scientist can have it, and the second was a Nobel Prize. So was interesting one, but the one that I'm going to talk about today is about a discovery that in my mind has changed our life in many different ways out of it. It's an AlphaFold. I think the prize was won by, I'm sure, not think, I know the prize is won by jointly by Professor David Becker and the DeepMind team, uh, uh, you know, John Jumper, and the Demis Habbassis. So amazing discovery. So I'll just kind of talk about what AlphaFold is and why it is important. Correct. So if you look at a human body or any living species on this planet, the cell plays a very important role. Cell biology is a beautiful kind of field of study. Within cell biology, there are different molecules that interact with each other, and they are like machines that work together to ensure that our body functions as it's supposed to do that. And these are like, you have a small molecules like ligands and bunch of chemical interactions that happen, and then you have a big molecules which are like your DNA, proteins, and some of the things. It so happens that understanding about this molecules has been very limited in up until now. For us to be able to understand how these molecules function, it takes years and years of research. Correct. And 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 then you kind of take this understanding and then translate into something which is more applicable in our real life. This could be in drug design. This could be in solving problems like how we can kind of reduce the pesticides, sorry, how we can reduce the disease in the plants, or maybe just understand like all the living organisms around it. Correct? So it's a pretty interesting in that perspective. So this is like, I highly recommend, this is the starting point for anybody to understand what AlphaFold is. I think it has like very clearly articulated what is AlphaFold, why it is important. But I'm going to start. I've already talked about like small molecules and big molecules and proteins, especially, which are kind of which was the starting inspiration for DeepMind team and all the other researchers in that area to be able to start with. So the initial version of a protein design was, and a lot of research has been done by Professor David Becker at University of Washington, and a lot of work has been kind of built on the foundation of Professor David Becker's work. That in here you can read more about different research that his team is doing, translation software, and also in responsible AI. Because when you have a technology like this, how do you ensure that it has been used in a right way out of it? So I think it's great to see that they have a focus around. There are different labs. So Professor Backer's lab, there are like Professor King's lab and Bhardwaj lab, and you can kind of basically read more about what they're doing. If you are new, you can start with the beginner's guide and understand what is protein design look like, the research papers, and things out of it. But as I mentioned, so we wanted to learn more about protein, and how do we do that. So there was a competition. There is a competition called CASP, and it started in 1994 to understand how we can learn more about this building blocks of our life or machine, and not just understand, but how we can accelerate this research process and this understanding process out of it. And what does happen is that this competition basically have different categories, and it basically invites researchers all across the world to submit their findings, that okay, how would they predict a particular protein or a set of a protein. And if they are, and they have a ground truth, and they know how that protein kind of folds and then structures, and people submit the result, and they kind of see how closely their finding matches with the ground truth, or which is the actual protein design look like. So up until like I would say 2000, I would say 14 or 16, correct, the state of the art model had an accuracy of somewhere around 50 to 60%, correct. DeepMind team kind of came up with the first version of AlphaFold sometime in 2018, and they had kind of really took that kind of prediction level, which is measuring GDP, which is a global distance between like what exactly a protein is supposed to kind of fold or come up with a design, to almost around 70%. So that was a significant jump. AlphaFold kind of experience at the first time. And the second version of AlphaFold, which is AlphaFold 2, kind of took that to 90%, which is the solution range that we have there. So I encourage people to kind of go through this competition, and see different applications and different submissions by different team, results, and rankings there. AlphaFold also is public. So this is the paper that they published this is in 2021, and this is for AlphaFold 2 in terms of how it does very high protein structure prediction around it. Super nice. At the heart of it, it is based on the reinforcement learning, and if you want to understand more about how, from a model architecture perspective, this is the article I recommend, which is the illustrated AlphaFold. It goes into a different section of the model architecture, like how does it prepares the inputs, how does it do representation learning. Basically, it is a two-stage process. Stage one, it creates it kind of predicts the structure of a protein, and but it also tries to understands from existing database, and try to matches with like how good, or what the fold should look like. And in stage two, it basically kind of creates a spatial space, and kind of try to understand what are the different distance between atoms, how does it interact with other molecules, and kind of looks it. So very very interesting process out there. And AlphaFold 3, which is the latest model, so here it just does not predicts protein structures, but it also kind of comes up with how does it interact with small molecules, like RNAs, DNAs. I mean, small molecules like ligands, and also proteins, also the structures of like beyond protein, like RNA, DNA, and other things out of it. So very interesting discovery they have made. uh, I just happened to kind of stumble upon this during my time, with Google research team, but I did not know much about protein structure and AlphaFold, and they have created now this wonderful course which anybody can take it. It's a 3-hour course where they explain what is protein, why they are important, why the protein structure is important, how does it kind of translate this into some of the real world applications. They go deep into AlphaFold 2 and high level overview about it. And so anybody can understand this at a much detail out of it. So highly recommend visiting this particular institute. Now, the output of this research is that because of AlphaFold, we have been able to map almost all protein structures which is available in human life. So which is in my mind and really really interesting discovery. And using
Great.
those protein, you can actually kind of learn more about the impact of life and so think about like a couple of problems that I'm particularly excited about is one about an impact of deadly disease. So we had coronavirus and pandemic,
Yep.
a few years back. Imagine if we know what how would a particular protein kind of folds or the 3D structure of it. We can design better vaccine that has a higher efficacy around it. So that's a
Yeah.
really really interesting one. The
Yeah.
second one I'm particularly excited about is understanding. So there are almost like no we have so much of plastics around us. In fact, there's a research that says almost 90%, 91% plastic never get recycled. Now if we understand the plastics at much deeper level, we can create enzymes that can
Right.
eat these plastics, and it kind of reduces the
Yeah.
plastic burden on this particular planet. So there are the application of this
Yeah.
discoveries is countless in both biology and chemistry in my perspective there. And you can
Yeah.
understand different. So let's say if I want to search about a particular protein like ORF8, which was responsible for coronavirus, and you can correct GTP binding protein, and I want to understand more about it. So this is how the protein structure looks like, correct? And here you can see the I think the red one. Sorry, the blue one is a prediction by AlphaFold, and the yellow ones are the one which how the ligands basically kind of interact with each other. So using this particular structure, it allows drug designers to kind of build a drug which is highly targeted and highly effective out of it. The last thing I want to highlight here is that there are very interesting tools that people can use it. So uh, in here we have three tools that I want to highlight. Is that I already showed you the PDB, which is a protein data bank that people can use and learn more about 3D structure of this protein. But there is an AlphaFold server that is available for people to use for academic research. And in AlphaFold server, what you could do is that you could enter the different protein details, or you can also enter small molecule details and try to understand how it functions there. And it is open for everyone, for people to kind of try and use it. And the last one I want to highlight is an AlphaFold 3 model, which is kind of open source as well. So people can kind of just have a look at it, try it, maybe re-implement some of those things on their research systems, and see how does it function out of it. In my mind, I think I'm kind of still learning about this. This is a process for me to still grab and things, but this really got me excited about what could happen. What could happen, with this research discovery.
I'm reminded of this quote. The more that they understand science, the more that they believe in a greater force and a greater universe. Kind of saying that, the more you help unravel how the world works, you have a greater appreciation of whether you call it intelligent design or whatever, just the complexity of human life. And um, these folks, they quite literally did God's work. It's brilliant. It's absolutely. It's humbling. Um, I mean, just to kind of add on to what you said, Dushyant, India is actually currently like the cancer capital of the world, and it is from a layman's perspective. I don't think we have very clear answers as to why. I think there's a broad guess, in terms of diet, of, that lifestyle. There are vague things like that thrown around. But younger and younger people are getting affected by cancer. The statistics are overwhelming. And if we get to a point where we can better understand what is really happening, um, just bridging the gap between the world we've created and the gaps in our understanding of it. This seems I think this is what the word awesome was made for.
True, true. And I think it was Albert Einstein. And and he said that the more I study science, I'm amazed by the complexity of our universe. And it kind of
Yeah,
drives
yeah,
him to learn more about it. And true, I mean, I think the reason why I
yeah,
wanted to highlight this particular breakthrough because there's so much of fear about AI, and rightfully so. I don't deny that. But I also
yeah,
want to kind of
yeah,
show that what AI done right can potentially kind of help us
yeah,
learn more about it. So I think the key word here is
yeah,
done right, and and
yeah,
I
yeah, yeah,
think such an amazing discovery that a particular technology has kind of gifted
yeah,
us, and we are so thankful of work done by
yeah,
Professor Becker and everybody else at DeepMind.
Yeah, yeah.
precisely.
Amazing stuff, Tushan. Thanks for sharing. And
Yeah,
I feel, with these kind of tools, right? Like, I think a lot of this work can be democratized, right? Like, you know, previously only bigger
yeah,
companies with a lot of tools and resources could be able to create or discover new drugs, right? Now, even in the conferences that we attended, and with the kind of open sourcing of weights and
yeah,
tools, I think a lot of the discoveries and solutions might come with people with lesser resources or lesser number of people, in the developing
yeah.
world. So I think it's an exciting time to be alive.
And if I would compare, I think Llama was kind of absolutely a groundbreaking moment in AI research and growth of what we have seen because the open source, the weights and other details there. I think similarly I see AlphaFold is that moment in the in using computational biology and computational science field where it can kind of unleash a lot of new discoveries there.
You know what I love about you guys, amongst the many things, that sometimes you just perfectly set me up for what I'm going to talk about. And literally, that's what you've done today. Today, I'm going to talk about exactly what Soham left us with, which is decentralization, and what really how the AI world is developing in terms of the resource allocation and just management of very important resources. I think just earlier today we were talking about how the while computing resource is something which the large techs don't see as a concern, especially with innovation and more elegant chip design. Data could be a shortage, and that's where a little innovation needs to happen. So let's talk about all of that. Okay, super. So over time, I think we've come to a conversation about heterogeneity of, let's say, training data sets, right? Just at a very basic level of having more data sets, more inclusive data sets leads to better decision making. Now, what about heterogeneous decision making? And where are we on that? And the heterogeneous models and its creation. So, and I think there's a little bit of a slow burn revolution happening in that direction as well. But let's go back right to the start. Um, while large organizations like a Google or an Amazon, or effectively some of the home ground for current large big tech AI discovery, do not see a computing challenge. That is not, as we know, the lived reality of most other people, right? Small universities, small companies continue to face resource crunches when it comes to computing power, when it comes to just horsepower in what they want to do. While Google has earlier this week come out with some real interesting breakthroughs in compute power, I think in terms of where we are today, that is still an open statement as to does a small company or university get the raw horsepower for what they want to do. And distributed computing has been around for a bit to help solve some of these challenges. To talk about where can we access latent resources on underutilized resources towards the solving of a larger problem. Close to home in India, we have entities like People Plus AI doing really interesting work with open cloud compute, where to code them, they're taking a DPI approach towards unlocking compute at scale. And it's kind of edge computing meets ONDC discoverability in DPI form is really what they're trying to do at People Plus AI. And obviously, in a country like India, which could obviously always appreciate better unlocking of latent resources, this is a made for India, made in India solution. There's also some really interesting solutions that have come out of something called Theta Labs, which has been doing, I think they got a patent in around September 23. I'm going to read out their patent title, which is to create an edge computing platform supported by smart contract enabled blockchain network. Where effectively they tried to, in a parallel or a very closely related context, combine edge compute network with the security of smart contracts and instant settlements and crypto transactions, which is while you have systems to unlock these underutilized resources, underutilized computing power, how can you enable it in a combination of A, smart contracts, and B, crypto transactions, which is effectively incentivizing everybody who is unlocking that potential as well. So they have something called theta tokens, where if you make your node available, you can potentially be incentivized for making your node available as well. So this is kind of, blockchain holy grail meets resource computing problem statement with some elegant token incentivization for your trouble. So that's where we are on distributed computing. Really interesting stuff. And definitely there's a lot of work happening over there. While sometimes, and if you can actually on the Theta Labs website, it's really interesting. You have a map which actually shows you the live nodes across the world. Understandably, a lot of them are concentrated in Northern America and so on and so forth. But also it would be great to see where the computing power lies in India and how that can be unlocked as well. But which brings us to point number 2, or like the other step in this is when this distributed computing is, of course, a solution for a paucity in computing resource. But where are we on data learning and how to best make that elegant? And of course, that's the solution to that, of course, is distributed learning, which includes pieces like federated learning and edge computing as well. Training, when spread over multiple machines or computer nodes, including a situation where you can learn from different data sets across multiple devices or data sets, is, of course, the rough definition of what distributed learning would include. I think there is one specifically that I wanted to call out is there is an organization called Flower Labs, which is doing some really interesting work in getting you from a 0 to 1 experience in your federating learning journey. So if you want to start setting up a federated learning system and try to ensure that your systems are adequately enabled, Flower Labs is actually a really interesting destination. It tells you all that you need to know. So this is roughly the story so far. Some of it is as old as time. Some of it is as old as AI. And we have been pretty efficiently utilizing these resources so far, which of course brings us to the relatively more recent advances, which is of distributed AI. Now, distributed AI, in some sense, is distributed learning on steroids, where you have two, let's say, large models of distributed AI. One is a multi-agent system, and another is a distributed problem-solving system. A multi-agent system involves having a network or a system of autonomous agents kind of throwing back to Soham what you talked about as an agentic ecosystem, and seeing how they can coordinate their knowledge towards solving complex problems. Whereas a distributed problem solving is taking a problem statement and dividing that work amongst the different nodes and knowledge sharing. And that happens whenever there's a problem too large or resources are inherently distributed. That is, you're going to have to access multiple data points to be able to solve your problem. This has been the story so far. In the background of some of these pieces, there has been an intent to create democratic AI, which is another layer above distributed AI. So the idea is, so distributed AI, we are talking about different models where there are multiple smaller either models, agents organize themselves towards solving a particular problem statement. Now, the question is, what if we were to translate that democratized action or distributed action towards governance? What if you were to say that in your participation as a distributed AI node, whether in terms of computing power or whether in terms of data source, you get to now vote and participate in the governance of an AI model? And that's what some really interesting folks are doing. There is this project called the Collective Intelligence Project. And what they are trying to set out to do is something along these lines. I'm going to read out some of their objectives and statements. One is understanding and actualizing collective preferences. Collective preferences informing high impact systems. And this is my favorite, not just gathering collective input. We've shifted incentives and built institutional capacity to compel action based on public interest. What that means is you are now an active, thinking, voting node of a distributed AI system, wherein you potentially get to have an opinion on the model itself. You get to have an opinion on if my data is being utilized towards a particular model, I do not want the model to be doing this. I would rather have a model doing this. And in your participation, influencing the decision making that happens. The idea is to create a greater overlap between those affected by AI decisions and those making them. And seeing that if you are participating in it, how do you really enable the space? There's also another organization called Roku AI, which is enabling this with the open space network through a DAO process. Like think crypto DAO, like a DAO company. Now, it is that organization, those decentralized autonomous organizations, wherein you were able to vote with your token. You were able to influence the decision making of the DAO, very much similar to the way a shareholder works, to now saying that you are able to influence the decision making of the direction which the model goes by voting through your participation as well. What is even more interesting is one of the people who have been thinking about this is nobody other than OpenAI. And in January of this year, they actually came out with a grant and they announced a blog post with their grant of some of these problem statements where they were giving grants out to people thinking about democratized AI tools, including a very interesting project called Inclusive AI. And that was also like the super interesting organization, which is trying to create AI systems which are more democratic and participatory.
Super interesting, Saranya. I think the couple of things that you mentioned resonated with me was around the potential of and then how decentralized AI is kind of no is progressing and advancing and things around it. I remember the collective intelligence project. I think there's a pretty interesting talk
Yeah.
that I was kind of listening around it,
Yeah.
and also how the different compute infrastructure has been evolving to be able to kind of make this effort and India's role around it.
Yeah.
I don't know when you mentioned about the Roku AI, is it that the thought experiment that you're talking about, where how super AI is basically kind of going to
No. So unfortunately, the association has not been helpful, I think, in their brand building. But actually, it's a separate system. So there is
Uh-huh.
the open space network, which is an entity which otherwise also helps in
Okay.
creating distributed AI
Okay.
systems and resource management. So it is distributed AI meets kind of distributed computing, but manage
Throw it out.
distribute computing through a DAO. So enabling an decentralized autonomous organization towards distributed computing. So they get to choose. So all the distributed computing
Participate in that.
nodes
Yes.
get to participate in the creation of the distributed AI in a more lucid manner. Yeah, that's at least the really cool moonshot
Nice.
that these folks are up to.
So from my side, I think for a lot of I think educational institutions, governments, right? Like, I think I've seen so many like universities in India not having any access to any resources, right? Whether it's training,
Yeah.
inferencing, right? And getting them together on the same board to achieve like to create models, and I think it's a great idea, right? I think, yeah. How do we execute it, right? This sounds like a very lofty goal, right? So would love to hear the kind of counter argument or your thoughts on that side.
No, 100%. And I think that's where it sounds a little too good to be true. And I'm a little skeptical as well. But let's run with it for a minute, right? See, I think even in like a standard distributing learning setup, one of the problem statements that you have in, let's say, for example, simple data parallelism, which is when you have multiple data sets across different, when the data sets are divided and you're having models running on each of those. The problem isn't just making those data sets congruous, making them of this similar pattern, making sure there's no dissonance between the different data sets that operate. And let's say even if you're doing model parallelism, making sure that all of that converges in a logical way is one of the reasons why, let's say, there is a substantial glitch to this. So one is from a pure resource management perspective. But if you're telling me that we can come to decision making as seamlessly, uh, I don't know. That sounds pretty utopian. Uh, and it's definitely one of those situations where I am very keen to be wrong, that this is very much more plausible than it sounds. But yeah, I think that's what's currently happening. I mean, let's not uh, let's not have utopia get in the way of, let's say, raw capitalism. I'm sure somebody still needs to make commercial decisions and see what what models or what projects are most economically viable. But just the idea that you can be a little more active participant of where your data is going and in what direction, I think that's an interesting thought experiment to at least start off with, right? Because we are nodes every day in some format or the other. Maybe it's in a privacy preserving way, like in a federated learning uh, context. Maybe it's, a little more raw data. I don't think we all completely know. But the idea that in the future, if we want to have a perspective on the way that models are utilized, that we are going to have to be a little more conscious as consumers or nodes, I think is really interesting to just see where that conversation goes.
So I've had a chance to kind of at least look at some of the other models. Like Flower is definitely one of them, but a lot of time I think those have been associated with federated learning, and which is another form of decentralized AI, like that we talked about it. But this is definitely kind of taking to a completely different level at things out. So yeah, I'm excited about it, and but I also feel that, see, and this is just my observation here. I and again I have that very healthy skepticism, as you also pointed out, that today's AI is built on data, correct? And the more the data availability, the more kind of the better AI is, what kind of we're trying to kind of look at things out of it. And um, And there was like, I was talking with Soham as well. There's an interesting observation by some of the AI thought leaders that we will soon run out the public data available for us to train AI systems on it. So we'll have to, but there is enough and more data which is locked inside, like, large organizations, rightfully. So so you will see and new approaches of AI kind of, coming into picture. But I'm just try to take a leaf out of federated learning model. It hasn't kind of, achieved its true potential. I'm sure the modeling itself is a complex. I think there are other challenges in terms of, like, implementing and building. There are a handful of examples where federated AI has been, but I sincerely hope folks who are building decentralized AI learn from this and kind of, maybe implement and take things out of it. But no doubt, it's fascinating.
Like this is, let's say, an example of
Hmm.
a dream situation.
Hmm.
I think picking from Soham's experience and even from like an AlphaFold, if tomorrow a community of hospitals couldn't come together and say that just amongst the resources we have, with the data that we all each individually store at our hospitals, creating a distributed AI system with federated learning, and enable each of these hospitals to participate in the decision making of the direction that we want the project to go. Imagine that, like having a bunch of hospitals just saying that we are going to create our best shot at understanding
Cancer,
the ailments
cancer.
that we
Yeah,
best
yeah,
understand, whichever,
yeah, yeah.
rather than it coming outside in of somebody serving the hospital. There is an opportunity for the hospitals to like daisy
Yes,
chain amongst themselves and say,
yes.
can we then become the distributed AI and we participate in this? Uh, that's a hell of a utopia, but I would
So,
really
so
like
I
to see
think there's a
that.
very in a different scale. There's an implementation of something similar called Health Research Network in Netherlands. Yeah. So where all the hospitals are connected, and the data doesn't really go out flow between hospital. Actually, model is kind of, passed on it as a train. And so I think, I definitely see, like, things kind of, scaling and evolving from there. Very interesting.
That was super fun as always, and it was great catching up with all of you. Um, I think today we had like a role flip where Soham sent us on an existential crisis. Dushyant was like holding the balance and being like look at the cool stuff happening in the world, and then I went optimistic. This was a
Yeah,
journey that we went on.
yeah. But I think
But yeah,
it
yeah,
was rightfully, this is end of a year. We close this year out. So I believe this is the last recording we'll do for this year. And hopefully next year we'll come up with some more interesting and thought provoking AI innovations for our audience.
cool.
Thank you.
Thank everyone,
Bye.
folks. This is a
Bye
pleasure as
bye.
always.